Section 4 of Chapter 6 is entitled Factoring Special Products. And what happens with these is there are certain trinomials or binomials that you should start being able to recognize, and they should be quicker and easier. Now here's the secret. If you don't recognize them right away, it's really okay just to use that backwards FOIL and keep doing what you've been doing. I'm going to show you some shortcuts, and if you can recognize these shortcuts, it's going to make your life easier when you're factoring. But if you don't recognize them, it's okay to just keep doing it the way you've been doing it. All right, so those special products, the first one we're going to be talking about is when you square a binomial. When you square a plus b, what's happening is you're going to end up squaring that first term and squaring the second term, and that middle term becomes the two terms multiplied together times 2. So let me just make up one. If you've got, and I should have, see, when I make stuff up, this is a problem. But if you've got like x plus 2 times x plus 2, and you know what, I'm going to change that to 3 because it's hard to tell when is it squared and when is it times 2 if you've got a 2. X plus 3 and x plus 3, and let's multiply these together. So x plus 3 squared. When you do your FOIL, you're going to multiply the x times x, and that's where the x squared comes from. And then your outside and your inside is 3x, and your inside is also 3x. And your last terms are 9. So that's where we get the a squared is that first term squared, so that's where your x squared comes in. Your b squared is your last term squared, so 3 times 3 is 9. And this 2ab is 2 times multiplying your two parts together. So x times 3 is 3x, and then you have 2 of them, so 3x plus 3x, that would be your 6x. So 3x times 2 is 6x. All right, so that's where it comes from. Now let's do it backwards. So what happens when we look at these, and if you say, well, I don't recognize anything and I'm just going to FOIL it, what happens is, oh, this is a perfect square. That's just y times y. This is a perfect square, 6 times 6. But 6 plus 6 is 12. So that's how you can recognize, oh, if these are both perfect squares, y times y is y squared. 6 times 6 is 36. If when you multiply those two together and double it, you get your middle term, then you know you have a perfect square. So this one you can just recognize and say, oh, this one is a perfect square, so y plus 6 squared is my final answer. Because when you take your outsides and your insides, you'll get 6x and 6y and 6y. 6y plus 6y is 12y. Okay? The same thing happens if you've got numbers in front of your first variable, because you can look to see, well, this is a perfect square. 9 is 3 times 3, so 3y is the square root of 9y squared. So 3 times 3 is 9, y times y is y squared, and 5 times 5 is 25. So now if you can take this times 2, then it's a perfect square. So 3y times 5 is 15y times 2 is 30y. So that is 3y plus 5 quantity squared. Now if you didn't see that and you did, oh, I think it's, and you ended up with 3y and 3y plus 5, that's fine. Then recognize at that point, oh, these are exactly the same. So then simplify it to 3y plus 5 quantity squared. Okay? All right. The next kind of special product that we have is the difference of two squares. The difference of two squares is when I have a squared minus b squared. And that comes when I have a plus b and a minus b. I'll show you. Right here, n plus 2 and n minus 2. So if these binomials are identical except for the sign in between the two, then what's going to happen is this. Watch. When you do your FOIL, first is n squared. Your outsides are n times negative 2, so minus 2n. Your insides are plus 2n. and your last terms are positive 2 times negative 2 is negative 4. Now, when you combine your two middle terms, because one is negative and one is positive, but they're the same, they totally drop out. They cancel each other out. If you have a negative 2n plus 2n, it's nothing. So you end up with n squared minus 4. All right? So that was going forwards. Now, if we go backwards, we can see, oh, well, n squared is n, and the square root of 4 is 2. So to get those middle terms, you're going to have plus 2 and minus 2. So let's do it with this one. Same type of thing. So x squared is x and x. In order to get a negative 49, 49 is a positive, or is a perfect square. It's 7 times 7. To make that negative, one has to be positive and one has to be negative. Because they're exactly the same but opposite, that negative 7n and positive 7n is going to drop out in the middle. So this is your factored form. Okay, let's do another one of those. What about 9x squared minus 16? All right, see if you can do that one on your own real quick while I'm writing it down. 9x squared minus 16. All right, so hopefully you can just see immediately, oh, that's a perfect square minus a perfect square, right? Because 9 is 3 times 3, x squared is x times x, and 16 is 4 times 4. So what you're going to have here is 9x squared, the square root of that is 3x, so 3x times 3x is 9x squared. 16 is 4 times 4. To be negative, one is positive and one is negative. And then your outsides and your insides, negative 12x, positive 12x, drops out. All right? Okay, so the last one I want to do is this. Be careful when you're factoring, even with the special terms, always, 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 your first step is to see, is there a greatest common factor between the factors that we have here? In this case, 2x cubed minus 2x, you've got a 2 in common, pull it out. There's x in both of these, so pull that out. So what you have left is x squared minus, now be careful. You can't just leave that, oh, all I have is left is an x squared. You've got to account for this minus 2x. So since we took the whole 2x out, what's left here is a minus 1, because 2x times 1 is negative, is 2x. All right? So you've got to keep that, you've got to have, if you've got two terms in your first polynomial, you've got to have two terms once you take out the GCF. Okay? So once you get to this point, then you got to keep going. You say, okay, is what is in here finished? Is it totally factored, or will something else come out of that? And in this case, you can recognize, oh, that's a perfect square minus a perfect square, because x times x is x squared, and 1 times 1 is 1. All right? So don't lose the 2x. And x times x is x squared. 1 times 1 is 1, plus and a minus gives you a negative 1, and negative x, positive x drops out. So this is your factored form. All right? So today is a lot of the same thing again, except that, see if you can start recognizing some of those perfect squares, the perfect square trinomials that look like this. And I didn't do any that had minus. If your middle term is negative, that means that you're going to have a minus b when you factor it out. And then if you have a perfect square minus a perfect square that you're factoring, it's going to just go back to a plus b, a minus b. All right? See you soon.